I spend most of my life here in looking at the logs from these events in S3 buckets on Amazon. So what do these events look like? Fairly standard stuff. They are JSON, gzipped with information about each event, the user ID, the timestamps, that sort of stuff. We get about 10 billion of these per day, so that's a lot of data to process. We're not Google scale or anything like that, but it's still a lot of data. So the way I'd analyze this is I'm a big fan of Spark. How many people are actually using Spark for data analysis? Couple. Is anyone using it in production? Yeah, I want to find out more myself. So I get all these events, and using Spark, I use Spark to reduce it down and get it into a nice format, like a data frame. So Spark has its own data frame. I'll talk about that in a minute. If I can reduce it down even further, then I'll start working in Pandas and scikitlearn. I haven't yet got to this stage, but this is something I'm exploring now, actually just using Spark's machine learning library. So just a little bit about Spark, if you don't know. It's an Apache open source project that grew out of the Hadoop ecosystem. It has 4 components. One is called Spark SQL, which probably should be called Spark dataframe, because that's where the whole thing is going. I think Owen mentioned, or various people have mentioned how much they love dataframe, so I think that's becoming the real primitive for data science now. It has a streaming component if you're doing streaming processing, and a load of good machine learning stuff, and also some graph processing. So the sort of science fiction future is, if you're using Spark, you don't have to care about how big your data set is. You're dealing with a data frame and you're doing your analysis on the data frame. That's the future. We're not quite there yet, I don't think. And the Python support is almost as good as Scala. It was lagging behind, but now that they're moving to this data frame primitive, Spark and Scala perform about the same when you're doing operations on a data frame. When I want to prepare my data, so I'll just slightly cut off there, but if I'm looking at a specific mobile app, it may have launched a year ago, but if I'm building a model and analyzing data, I want to look at more recent data. So there's a whole load of steps. Data munging takes forever. I don't want to go into the gory details. It's no fun for anyone, definitely not for me. But this is the sort of end goal that I'm going for. So it's for every user, we have a vector of attributes, and might have demographic information here, and then when they first purchased, when their first session was, and aggregated data like their time in app and lifetime spent. And then I'll also have event data. So this is for each day. There's a column. It might be aggregated, how much spend, how much sessions, and that sort of thing. So I use a Pandas data frame mostly. So we've seen a good bit of Pandas already. It's great. I love it too. So reading in data, dropping data. I made a mistake, so I can subtract 1 from a column, and it all works well. But this happens wherever. You're always cleansing your data. And then you can do df head to have a look at your data. And so yeah, I mentioned the Spark data frame. It's almost like a Pandas data frame. You have to be aware that you're dealing with distributed data across loads of nodes, and Spark data frames are immutable. So they're not quite the same, but they're getting there. And you can always do this: convert your Pandas data frame your Spark data frame to a Pandas data frame. That takes a long time, but then you have a nice Pandas data frame at the end if you have a small amount of data. The first step is exploratory data analysis. So I'm trying to predict churn. So a very useful explanatory variable for that is recency. So recency of a user is when we last saw them. So if I use the app yesterday, then I have a recency of 1. If I use it today, I have a recency of 0, and so So yeah, in Pandas, you can do nice things like describe a variable and you get nice summary statistics. But it's useful to plot it, obviously. So I use matplotlib, and you can just do dataframe.variable and then plot it. So this here is a histogram of all the users who were active in the last 28 days. What is their recency? So I can see most people who were active in the last 28 days were active today, and then that trails off. 28 days ago, maybe there was some type of campaign running, and there's still a lot of users sticking around from that. So which users now are active in the next 28 days? So this is leading towards trying to predict this. So here I'm setting up an indicator variable. If I saw any activity in the next 28 days, then yes, they were active in that time. So this lets me do a plot of all the users in the last 28 days who are still active in the next 28 days, what is their recency? So what I'm trying to do is I'm trying to put a more precise number on what churn is. So 50% of the users who were active in the next 28 days were active on today, most of them. And then this trails off. So if I take the 99th percentile, so only 1% of users who were active, say, 28 days ago are still active in the next 28 days. So that might be, for this app, a good definition of death for a user, of churn. In fact, we are looking at a lot of different apps, and games in particular, it tends to be a good bit less. It tends to be around 14 days. So if a user has been absent for 14 days, then pretty likely they're gone. And that enables you to do some more interesting stuff like survival analysis. There's a Python library for this called Lifelines, which is really good. You should check it out. So here, if I know that death is 14 days, that's when someone's going to churn, I can find out the probability of someone surviving at a certain amount of days after install. So after 150 days, the probability of this user still being alive is maybe 20%. The other thing I do a lot of is feature correlations. So scatter plots are great. However, in a big data setting, you often get a lot of points close together, and it can be difficult to see what's going on. So I recommend a density plot. So you can do that in MATLAB. And here you can see, so I'm trying to answer your question here. Do users play many short sessions, or do they play one long session? And here we can see, in fact, most users play one session and they don't play for very long. That's quite common as well. So another really important variable to look at is the spend of the user. If you plot a histogram with the lifetime spend, you can see most people don't spend very much. These are spenders. Most people don't spend very much, but we do have some outliers up here. So this could make you go back and check, are these players really spending that much money, or is that a real number? And in fact, for this app, it is. In the free-to-play setting, people do spend a lot of money. So leading on from that, a very useful tool I found in Pandas is the Quantile cut. So if you want to split your users up into groups, you can split them up by their quantiles. And this enables you to do some nice things like plot a distribution of the population of users in each quantile versus the amount of revenue they contribute to the overall game. So here, most people don't spend very much, they don't contribute a lot. But the top 1%, they contribute 30% of the revenue. And that's very, very common in the free-to-play setting as well. So just moving on to predictive analytics. You've got all that data nicely prepared, you've done your exploratory analysis, and now you want to predict something. So I'm a big fan of the random forest. So the basic component of a random forest is a decision tree. That's kind of got cut off there, sorry. So let's say you want to predict your churn just using two variables, the lifetime spend of the user and the recency. We can make a split on recency, and if the split here I'm making is say, if recency is greater than 14, then what happens? Actually, you can't see it, but the user is anyone who has a recency of greater than 14 days. We haven't seen them in 14 days. Then, in fact, they may have churned. And then that's the first split. So there's still all these users left over. So then we're going to split again. On this time, let's split on spend. So here, I'm saying if the spend is greater than 100, then maybe they haven't churned. If less than 100, then we still don't know. So I could stop there, and now I have a kind of a probability distribution for my users. So all the users who get down here, there's a chance that maybe they're slightly more green. So I can actually output a probability of them being not having churned. So that's the basic component of a random forest. You can go deeper. There's a whole load of tuning that we saw earlier that goes on. You can spend a long time at that. So there's another example. If anyone hasn't seen it, there's a lovely visual introduction to this stuff, a really nice D3 visualization available there. So a random forest is a bunch of these trees. So you can pick. So we talked earlier about having lots and lots of attributes and which ones are important. A random forest can generate a tree for a certain subset of those variables and give a probability of the class output. It turns out it's a very powerful result in machine learning that you can average over those trees and get something that's close to the truth. So you've a whole lot of weak classifiers and together they make a strong classifier. So yeah, why do I use them? I'm a fly by the seat of my pants data scientist, and they're just a really, really handy tool. They let me do everything I want in a sense. So they can handle regression and classification. They can handle multiple classes. There I was only trying to predict one class, had they churned or not. They can do regression. Very important in our use case is that they are scalable. So you could essentially train a different tree on each node of a cluster. And yet they allow probability estimates for the classes. They also turn out to be really accurate. So each tree is very sensitive to the data you put in it, but working together, they can collapse to the truth. So this is the truth. This one, there's a low bias tree around it, very variable, and another one, and then they collapse to the truth. That's very hand wavy, but that's kind of why they work. A really nice feature of a random forest as well is you can output. You can do all this in scikitlearn. They can output feature importance. So surprise, surprise. If we saw, like you talked about in the Ryanair example, if we saw the user very recently, then they're not likely to churn. So it's one of the most important things is what were they doing lately? That's one of the biggest discriminants of whether they're going to churn or not. But this is a great way of finding out what are your important variables. We also talked about you want to assess the quality of your model. So there's loads of different metrics. I'm a big fan of the receiver operating characteristic. So these forests output a probability of being in a certain class, and you can set a threshold. So say I set the threshold at 100%, then well, I'm not going to find anyone in the class, it's too high, but I'm not going to have any false negatives. So this is true positives against false negatives. But as I relax that threshold, then I find more and more positive instances, and my false positive rate starts to go up. You want to be way up here. You want your curve to be right up here. So very few false positives and loads of true positives. So 93% would be a pretty good result. And that output of a class probability is useful in a marketing context because you can then use it to target samples of users of a given size. Which is what I'll talk about now in a minute. Oh yeah, so I think there's a workshop on scikitlearn tomorrow. So it's very, very simple to do these types of things. I split up my data set into a training and classification set, pick my features, do the model, train, fit, and predict. You go into more detail on that. The Spark implementation in machine learning library is very, very similar. You load, I won't go through it all now, but you load, train, predict, and evaluate. And as Owen talked about later, Spark is really good for building these pipelines of different steps in your data analysis. So collecting the data, transforming it, ETL, all that sort of stuff. So lastly, you have all these nice predictions. So how can you use them? So we recently ran a campaign on an app. We looked at about a month of data. We trained a random forest model, identified the top scorers, and sent them an offer of free coins. So please keep playing, here's some money. We actually sent it to everybody, all of the different bins of users, so not just the top 90% of users going to churn. We want to evaluate what happens when you send it to everybody. And these are the results we saw. So we were actually able to reduce churn overall by 11%, which is great, and increase session time. However, looking at the revenue, we might have regretted something here. So we sent it to everybody. So the people in the very high, who were very likely to churn, we saw their revenue go up. They were going to churn anyway. We gave them some free coins. They stuck around and they kept spending real money. However, when we sent it to the lower bracket, it turned out they spent less money. They got free coins and they said, great, thanks very much, but I'm not going to spend any more. So there's a problem here about optimization. So all these people are going to churn anyway. All these people are going to purchase anyway. So there's probably a sweet spot in here where you offer the discount. But you're still going to try and minimize your regression. I think I've gone very fast through this, but anyway. So currently our research at the moment is around looking at different types of predictions, more models, trying to predict spend, actually trying to predict the response of users to different types of campaigns. I'm really looking forward to Connor's talk tomorrow. I think he's going to talk about response modeling. So will users respond better to a push notification or an in-app message? Going back to that optimization problem, we want to look at reinforcement learning approaches. So things like multi-arm bandit, multi-agent learning models. So we want to have maybe lots of campaigns running at the same time. They might all have different specific goals. One is to reduce churn, one is to increase spend. But together they have a common goal, which is, don't impact revenue. So how can you get them, how can you optimize that in the best way? So this is all research, we're trying to figure this stuff out. And then, of course, operationalizing the whole thing. So Owen talked about building a data product, and that's a very hard thing to do. You have to monitor your data, make sure the quality of the model is still good, and that sort of thing. So Spark, I think, is going to come in very, very handy there. I think that's it. Thanks very much. If anyone's involved in that area of reinforcement learning or just is interested in general, just give me a shout. I'm going to try and put up some of that analysis I was doing on a GitHub repository. I have the same issues about data, so I have to be careful that I've anonymized everything, but I'll try and get it up there. Sure.
Do you run Apache Spark on Amazon EC2 instance, or do you do it in-house?
We run it on EMR, on Elastic MapReduce, so yeah, basically, yeah. It's really handy. We're basically an Amazon shop, like all our stuff is in Amazon. Okay, thanks very much.